Hi, hi. This is Sivaranjani, Assistant Professor from the Department of Computer Science and Engineering. Today, I'm going to cover a topic of clustering approaches from Unit 2 from the subject U18Pecs023 Machine Learning. In this video lecture, I'll be covering about introduction to the clustering techniques, what are the techniques that are available, and also we'll be covering one important clustering algorithm called k-means clustering, which comes under the classification partition algorithms. Before we see about the K-means algorithm, first let's see about what is clustering is. Clustering is nothing but a grouping of elements based on its similarity or based on some criteria. Suppose I have a large group of people and I want to group them according to their height. So there will be height is like taller, a normal weight, and the short. So I'll be taking the height of each and every person, and I'll put each and every person in these three categories like taller, short, and normal height. Okay, so this the way of grouping this grouping we call it as clustering, and this all the clustering algorithm that comes under the learning and supervised learning, because unsupervised learning are the one where we don't have any information on the prior data on prior, whereas we have supervised learning also. This supervised learning, we have some knowledge about the data and the labels. So if we know about something about the data and the labels are already known, then we call it as supervised learning. Whereas since clustering, we don't have any prior information on the data, and we are just going to group the data as and when the data comes, and we are going to take the features or analyze the data. That's why it is called as unsupervised learning. So, and also this is a method of data exploration because we don't have any information about the data prior. So we are going to explore the data and then we are going to perform the clustering. So that's why it is called as unsupervised learning. And there are so many clustering techniques available in the market and now, and all the clustering techniques were invented bit 40 years ago, and since after many years, there were so many clustering algorithms that are available and reported by the researchers. And still now, most of the clustering algorithms are still available and used by the market recently. And in this video lecture, it is quite impossible to cover all these clustering techniques. So we emphasize on the major technique called partition techniques. And under partition clustering techniques, we are going to cover the k-means algorithm. And we have two types of clustering algorithms. One is flat algorithms and hierarchical algorithms. Flat algorithms are the one, as I already said, this is unsupervised and we don't have any information about the data prior. So flat algorithms works by taking some data randomly from the entire data set and groups them based on some similarity or dissimilarity measures, and once as and when the data is added to one group, it is iteratively refined so that the accuracy of the clustering is high. So the flat algorithms works by randomly picking the partition data and iteratively refined so that we get a higher accuracy. And the hierarchical one is we go by top-down approach or the bottom-up approach. So we under hierarchical algorithms we have bottom-up, which is also called as agglomerative clustering algorithm, and top-down, which is called as divisive. So we take a data, if we divisively cluster go by dividing the data sets and we cluster it, then we call it as top-down. And we have an entire data set, and we grow by clustering the algorithms by grouping the data, then we call it as agglomerative. And we also have hard clustering versus the soft clustering. So hard clustering are the one, each and every data will exactly belong to one item, exactly belong to one cluster. Then we call it as when we call it as a hard clustering, and it is very easier to do because we are not going to complicate much about the data. And soft clustering are the one where one data item belongs to one or more clustering grouping. Those type of data we call it as those type of clustering we call it as soft clustering. And now we are coming to the algorithm, k-means algorithm. So k-means algorithm is the comes under the category partition algorithms, where we randomly take and it also a flat clustering algorithm because we are going to take randomly take the data items randomly in the initial, and then we are going to iterate that cluster uh, to increase the accuracy of the cluster. So it is proposed by Harrington and M.A. Wong in 1979. So we get given a set of n disjoint objects. So n is nothing but the data items we are going to give it to the algorithm, and the algorithm k takes that n disjoint items and partitions them and creates a k number of clusters. So k is nothing but how many clusters we are going to create for this n disjoint objects. So n is the size of the entire data set, and k is the number of clusters we are going to create for that n disjoint items. So if this is happening, we are going to group these n objects into k clusters by calculating the similarity measure. So when we calculate the similarity measures, the data items which belong to the same cluster should have the highest similarity among when compared to the data items that are present in two different clusters should be should have less similarity. So this is given as intra-cluster similarity should be high and inter-cluster similarity should be low. Okay, so this is what whenever when we go for doing the K-means algorithm, we'll be giving n disjoint items and k number of clusters. K number of clusters. So whenever we start doing the K-means algorithm, we need to specify how many clusters we are going to create out of the entire data set we have given. So that means that that takes the algorithm name as K-means. So this is the steps given for K-means algorithm. So first it direct k number of objects at random from set of n objects. So as I said, this is a flat clustering algorithm. So we when the entire n data sets are given, n data points are given, we are going to randomly choose some data items for calculating the centroids. So first step is to randomly take the data items, and the next step is to calculate the centroid for our center of gravities for n clusters. So as we said, if out of n objects, suppose I take three data items. So three data items means that I am going to uh, create three clusters. So k is equal to 3 here. Okay, and now since this is the initial step of my data clustering, the k this k three data items remains as the centroid for my cluster, and then I'll take one more data item and create the and calculate the similarity measure between all the three data items which I have taken initially. Okay, so the next data item, I mean the fourth data item given will be given to the cluster to which the similarity is very high. So the and once a new data item is given to the particular cluster, the centroid is recalculated. So whenever, when and where, as and when the data item is calculated given to the cluster, the centroid is recalculated. So this procedure goes on, and this is repeated until all the data items are given assigned with all the clusters, and also there is no change in the centroid value. So this goes in the repeated fashion, and that's how the K-means algorithm works. So this is the actual algorithm for K-means. So T is the data set containing n objects, and K is the number of clusters. So D is the we are going to represent the entire data set as the D, and in the data set I'm going we are having n objects, so n data items. Okay, and we are also going to have we are going to set k clusters. Suppose we say 3 clusters. So if it is 3 clusters, the initially we'll be taking three random samples from the data set. Okay, the first one step one goes like randomly choose k objects from D as the initial cluster centroids. Suppose I have, as I said, suppose I have k is equal to 3, I'll be taking 3 data items from the data set D for each data objects, after which for the each object in the data set, compute the distance between the current object and k cluster centroids. Okay, so current object, I have one current object, and k cluster centroids. For this example, we have taken three cluster centers, and we are going to calculate the similarity between the current object and the three clusters, three data items. Then assign the current object to that cluster to which it is closest. Okay, so the current object has the maximum similarity with the cluster 1, then we say that the current object belong to the cluster 1. After giving this the current object to the cluster 1, the cluster centroid is recalculated. Recalculated, either there are two options, either the new data item, the current object now changed to the cluster centroid, or the previous one will be the cluster centroid. Whatever, whenever the data item is given to the cluster, we have to recalculate it. Okay, and this is step 3 goes like this: the calculate the cluster centers for each cluster, and repeat the step 2 and 3 until the convergence criteria is satisfied. So convergence criteria is nothing but if there is no change in the cluster centers, then we say that the algorithm is converged, and that is the stopping criteria. So here goes with an example. Suppose the objects are defined in the term set of attributes. So attributes, A represents the attribute set. Attributes are nothing but the important items, important features that we are going to consider, so that to check whether data item belongs to which cluster. For each AI is a continuous data item. So every category, every data here is, every attribute represented in the attribute set is called as continuous data type. Okay, okay, because the clustering algorithm doesn't work with the categorical data. That's why it is given as continuous data. And then the distance computation. So distance computation for this example, we are going to present an example. For the distance computation, we are going to use the cosine similarity as the similarity measure, and the minimum distance is the measure of closeness between the object and the centroid. And mean calculation, it is a mean value of each attribute value of all the objects. Okay, mean calculation. So when if there are two data items and three data items in the one cluster, so we are going to calculate the mean between all the three data items, and that makes the centroid. So convergence criteria is given with like maximum number of iterations permissible. Suppose I say that the maximum number of iterations is permissible is 10, then after 10 iterations the algorithm will come to an end. This is one criteria, convergence criteria. And next one is no change in the centroid. As we discussed earlier, as and when the data is given to the cluster, the centroid should be calculated. If there is no change in any of the cluster centroid, then we say that algorithm is converged and we have no changes anymore. And next criteria we can consider as zero movements of objects from one cluster to another. If there is no movement or no changes between the data items between the clusters, then also we say it is converged. And cluster quality reaches the certain level of acceptance. Suppose we say that it is 90% accurate, we are more and we are convinced about that, then we also can stop the algorithm. So this is the illustration of K-means clustering algorithm. Objects with two attributes A1 and A2. So we have two attributes A1 and A2, and each of the attributes have some values mentioned in the table. Okay. So when we have plot the graph for these two values A1 and A2, so this is how my graph will be represented with the values attributes A1 and A2. Okay. So as we said earlier, the first step of K-means algorithm is to randomly select some cluster centroids. Okay. It is completely random. We don't have any criteria or anything to be measured for calculating the initial centroids. So as far as this example is concerned, the red marked data points are taken as the cluster centroids. So which is nothing but 8, 12, 4, 10, and then 7, 19. So these are the three clusters we are going to we have taken. Okay, and now, and since we have taken three clusters, three centroids, then we mean that we are going to have three clusters. So k is equal to 3. Okay, and now the initial centroid is calculated. So initial centroid here we are taken as these are the three items 3.8, 9.9, the first data item 3.8, 9.9, and then 7.8, 12.2, and 6.2, 18.5. So these three are taken as the initial centroid, which is marked in the previous graph. Okay, and each one is, and now we are going to, since we have three clusters, we have three distances to be calculated for each and every data item, D1, D2, and D3. Okay, between the clusters C1, C2, and C3. Fine. Okay, now we take the first cluster, first data item 6.8, 12.6. 6.8 comma 12.6 is now compared with 3.8 comma 9.9. So this so this is the cluster centroid. So all the data item is compared with the cluster centroid. Okay. So now 6.12 comma 12 6.8 comma 12.6 is compared with 3.8 comma 9.9. So we have the cosine similarity is calculated between these two data items, and we have the distance one called 4.0. 4.0, and the same data item 6.8 comma 12.6 is now computed is now is compared with the data item 7.8 comma 12.2. 7.8 comma 12.2. Okay, and when we calculate the cosine similarity between these two data items, we have another distance called 1.1. Okay, and now the another thing is 6.8 is now calculated. 6.8 comma 12.6 is now again calculated for 6.2 comma 18.5. 6.2 comma 18.5. So when we calculate the cosine similarity between these two data items, we have another distance called 5.9. Okay, so now we are going to compare this distance 1, distance 2 and distance 3, and we are going to check to which the similarity is very low. Okay, so we are okay, so here the cluster the data point 6.8 comma 12.6 is given to the cluster 2 based on the similarity measure. Okay, so similarity measure, and similarly we calculate the we calculate for other data items also. So say 0.8 is compared 0.8 comma 9.8 is given compared with the 3.8 comma 9.9, we'll get about distance 1, so that is given as 3.0, and 0.8 comma 9.8 is given with 7.8 comma 12.2. We have another distance computed for 7.4, which is a 7.4, and 0.8 comma 9.8 is again calculated with 0.2 comma 18.5, which is the initial centroid we have taken, and we'll be getting distance 3, so 10.2. And now the least distance we have is 3.0. So the data item 0.8 is given to the cluster 1. So this is how we are going to take the initial centroid, the initial randomly based on the initial randomly taken centroids, we are going to first assign the data items to each and every cluster. So after giving the data items to each and every cluster based on the distance measure, this is how my graph now looks like. And then we have grouped the data items C1, C2 and C3. So in the data items in the cluster C1, we have 2, 4, 6, 8, 9 data items are given. 9 data items are given. In the cluster 2, we have 4 data items, and cluster 3, we have 3 data items. And still the cluster centroids have not changed. Okay. So after assigning the data items to the cluster, now we are going to compute the centroid calculation. We are now going to check whether the centroid remains the same or it is changed. Okay. And now we take the mean for all the data items that is given in the data, all the attributes A1 and A2, and now the all the data items which is there in the cluster C1. Okay, so which means that in the data table we will be taking 0.8, 9.9, 9.8, 1.2, 11.6, and what are the data items that belongs to the cluster 1. We will be taking only those attributes, those A1 comma A2 values, and we calculate the mean value. Okay, so after doing so, we have the attribute of the cluster centroid as 4.6 comma 7.1. Initially it was 3.8 comma 9.9. Okay, so initially it was 3.8 comma 9.9, and now it is 4.6 comma 7.4. Okay, similarly we are going to calculate for C2 and C3. Okay. And now so the old clusters are marked with a red circle, and new clusters are in old clusters are in marked as a black circle, and new clusters are given in red color. Okay, so now again the cluster centroids have changed, and then again we go and compute the centroids. Again we will be based on this centroid we start assigning the data 16 data items which is there in our data set, and start assigning to the cluster 1, cluster 2, cluster 3 based on the similarity measure. Okay, it may there after doing so doing so, there are two possibilities: either the data items belong to the same cluster itself, or there will be some movement in the movement of data items between the clusters, cluster 1, cluster 2, or cluster 3. So it is happening because of we have taken the new cluster centroid. Okay. And after calculating, based on the new cluster centroid, after assigning 16 data items, again the cluster centroid is calculated by taking the mean values of each and every cluster. So again the cluster centroids have changed to 5.0 to 7.1. So based on uh, this one, the data items are assigned. After the second iteration, this is how my cluster will be. So this is how a cluster will be. So this process is repeated until there is no change in the cluster centroid and there is no change in the change among the movement between the cluster data points among the different clusters. Okay, so this is the stopping criteria we have taken, and the newly obtained cluster at centroids after second iteration are given in the table. So this is the revised centroids after the second iteration. So these are the cluster centroids that have calculated after the second iteration, and we can note that there is no change in the cluster centroid, the third cluster centroids, so unremesh, and there is something some little changes in the cluster 1 and cluster 2 centroids, and again we'll be start doing the repeat the action for the cluster 1 and cluster 2. Okay, so when we repeat this all data items, and the 16 data items has to be reassigned again. Okay, okay, so if after reassigning also, if the data items remains in the same cluster even after reassigning the data items based on the new cluster centroids, then we say that the current algorithm is converged. Okay, when we don't have any changes and in the cluster grouping of information, grouping of data points. So this way the K-means algorithm comes to an end. Okay, so these are the advantages and the disadvantages of the clustering algorithms. So the first advantage we have is K-means is simple and can be used for wide variety of object types. Okay, so as we explained here, we are just assigning the data, calculating the centroids. Assign the data, calculate the centroid. So this is like a for loop, and repeated action. Repeatedly we are doing the same thing. Only two steps it is repeated. So it is very simple, and it is since it is simple, it is being used for most of the objects now. It is also efficient and storage requirement, execution time of the views. So as far as the execution time and the storage requirement is concerned, the k-means among the all other algorithms, the k-means algorithm seems to be simple and efficient. Okay, and then the limitations. So limitations is since we say that we have n data items and we are going to group it with three clusters, but this three is a random guess. This three number we are just going to group it with random guess, but we don't have, since we don't have any information about the data, since we are doing an unsupervised way, there may exist a four clusters or five clusters, but we are just thinking it as it is a three cluster where we are going to group. It may or may not be a good choice. Sometimes may exist at three groups itself, but there may be cases, in the first cases, where the number of clusters is four, but we have taken it as three. K-means finds a local optima and may actually minimize the global optima. So local optima is within the cluster we have reached the condition. Within the cluster there is no change. We don't have any change. If we take that items and if we say that one cluster is there is no change in the one cluster centroid, so we may think that the algorithm has come to converged, but we never we should always think about the global optima, means that we have to calculate check about all the clusters which are available that we have assigned. The next one is trouble clustering the data that contains outliers. So outliers are nothing but unwanted data. The unwanted data are like whenever we have an entire data set, the data set should be first remove the outlier unwanted information should be removed. So it is very the K-means algorithm is very prone to outliers, because if we consider the outliers, then we all assign the data items strongly so that decreases the efficiency or accuracy of the clustering algorithms. So outliers should be removed or it should be carefully taken care of when before we start with the clustering the data items using the K-means algorithm. And K-means algorithm cannot handle non-global clusters of different sizes and densities. So non-global items and the clusters of different size and densities. So we cannot say, as we saw the example, like the first cluster we have 10 data items, whereas the second cluster we have only 4 and third cluster we have 3. So we cannot mention or we cannot determine how many data items belongs to one cluster. And K-means algorithm is not really beyond the scalability issue. So, because of this K-means algorithm is, though it is simple and efficient, it is used for only small data set because computing the mean every time the data every time the cluster is constructed, it is for large data set, it is not useful, and it is practically impossible or practically not efficient for using this K-means algorithm for large database. So to summarize, the K-means algorithm is efficient and simple, and we have only two steps to be calculated. And this name, the K-means, comes because we are going to consider how many clusters we are going to construct. That means that what is my K value, and K means is how many whenever we construct a cluster, we are going to take the mean of all the data items. So that comes from the what K-means algorithm.